Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. Yes, I was a bit late for like 10 minutes. I'm sorry for that. So let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly, my dear students in the chats. Let me know quickly in the chats if all of you can hear me, if I am perfectly audible and visible to everyone. Good evening, people. Good evening. Good evening. Good evening. Everything is perfect? Yeah? All right. So, my dear students, today again we are going to discuss some amazing, I would say very amazing. Yeah? I don't know whether it's grammatically correct, very amazing. But some amazing concepts we are going to discuss in the today's session. And those concepts frequently have been asked in the NEET examination and will be asked in the NEET examination as well, because they are super important. They are super important. For example, there is a topic entropy, very important. I'll be discussing today. One topic is their Nernst equation, amazing topic, right? Frequently asked. One more topic is their pH, calculation of pH. Again, one more very important topic. Then there is Chatelier principle. Again, very important topic. Then there is Arrhenius equation, very important topic, right? All these very important topics, which are lengthy as well, right? I'll be discussing in the today's session. Duration of the session is going to be approximately 2 hours, or maybe less than that. I'll see how much time it's going to take me to complete all of them. Okay, so just tell me in the chats first, which part of the country you guys are watching me from? Which state you guys are watching me from? I just want to know first. I just want to know first. Let me know quickly in the chats. I just want to know that. I just want to know that. The chats are stuck. I want the chats to move fast. Vizag, Karnataka, Tamil Nadu, Madhya Pradesh, Kerala, Karnataka, Tripura, Dubai, Telangana, Tamil Nadu, Maharashtra, Bangalore, Bikaner, Tripura, Karnataka, KGF, Kashmir, Chhattisgarh. Nice. Good. West Bengal, Kashmir, Gujarat. All right, people. Nice. Kerala, Oman. Nice. Good. Kolkata, Vizag, Nagaland. Okay. Hyderabad. Perfect. Got it. People from everywhere have come, huh? That's great. That's the beauty of this particular channel, yeah? There is no language barrier. The channel is in English, yeah? So everyone is most welcome. Where am I right now? I am right now live from Srinagar, Jammu and Kashmir. Srinagar, Jammu and Kashmir. I'm live from. And I'm live from my studio, my home, right? I have made a small setup at my home. So I'm live from here. Okay. So first of all, the ones who have not smashed the like yet, liking the session is mandatory to mark the attendance. Yeah. Liking the session is mandatory to mark the attendance. So do it quickly. Do it right now. Every one of you. Do it right now, every one of you. All right, people, should we start then? Should we start? आपके टॉपिक्स आज AITS में आए थे. Of course, I told you they are super important topics. Chalo guys, let's start, let's get going, and at the same time, the PDF of this session. The PDF of this particular session I'll be sharing on my Telegram. The ones who are not the part of my Telegram yet, the name of the Telegram channel is WASSIM BHAT Chemistry Official. Well, this is the name of the Telegram channel on which I share the handwritten PDFs of all these sessions. Okay? This is the Telegram channel. The ones who have not joined it, so do join this Telegram channel as soon as possible. Okay? Because I keep on sharing every update, every important stuff on the Telegram itself. Alright, people, so should we start? Should we start the session? Should we get going? Yeah? All ready? All ready, people? Chalo, let's get going. Let's get started with the topic called as entropy. Well, my dear students, there are some theoretical questions which are asked from entropy. You will be given with a reaction and they'll ask you, what will happen to the entropy during the process? Is it going to increase? Is it going to decrease? Etc. etc. All of them, they're going to ask. And let me tell you how to deal with those sort of questions. First of all, my dear students, as you all must be knowing, entropy gives us what? Entropy gives us the degree of randomness. Entropy gives us the degree of randomness or the degree of disorderness. Entropy gives us the degree of randomness, or I would say the degree of disorderness present in the system. Entropy, it gives me the degree of randomness or the disorderness present in the system. Number one. The second point, more the randomness or disorderness present in the system, more the randomness or disorderness present in the system, more is going to be the entropy. So this is the first point, my dear students, which you need to remember so that you can easily solve the questions. First point, entropy gives me the information about the degree of randomness or disorderness present in the system. More disordered the system, more is going to be its entropy. For example, my dear students, if I talk about solid, let's say I've got solid, liquid and gas. Let's say I've got a substance whose solid form I've taken, whose liquid form I've taken, whose gaseous form I've taken. If I ask you to compare the entropies of solid, liquid and gas, can you quickly tell me in the chats, where would be the disorder more? Is the disorder going to be more in solid, liquid or gas? What do you think? The disorder will be more, the randomness will be more in gas, right? And more the randomness, more the disorderness, more is going to be its entropy, right? Entropy I'm representing with capital S. Perfect. My dear students, you must have heard, if I talk about solids, solids I'm going to classify into two types. Solids I'm going to classify into two types here. One is called as crystalline solid. One is called as crystalline solid and one is called as amorphous solid. One is crystalline and one is amorphous solid. My dear students, in crystalline solids, you have got ordered arrangement of constituent particles. In crystalline solids, you have got ordered arrangement of constituent particles. Whereas when it comes to amorphous solids, there is comparatively disorder present. So if I need to compare the entropy of crystalline and amorphous, what do you think? Which one will have more entropy? There is disorder present in amorphous. So I would say entropy of amorphous solid is going to be more than that of entropy of the crystalline solid, right? What is the logic? What is the reason? Crystalline solid, in crystalline solid, there will be definite, there will be ordered arrangement of constituent particles. Over here, there will be comparatively disorder present. We say there is long range order present, long range disorder present here. Or we can say, okay, I'm not going to go into the details. Let me talk in very simple terminologies. Crystalline solid, regular arrangement of constituent particles. In case of amorphous solids, there will be comparatively irregular arrangement of constituent particles. There will be disorder present. More the disorder, more the entropy. As simple as that, right? Now, my dear students, try to understand few more things. Remember these two statements. They are going to be useful in solving the basic questions. As the number of atoms in the molecule, increases, structure becomes more complex. And as the structure becomes complex, entropy automatically increases. What does that mean? For example, I'm taking CH4 and I'm taking C2H6. Let's say these are the two molecules I'm taking, right? In which molecule number of atoms are more? I would say number of atoms are more here. If number of atoms are more here, its structure will be comparatively more complex. And more the complexity of the structure, more is going to be the entropy. So if I compare entropy of these two, I would say entropy of C2H6 will be more than that of CH4. Okay? Right? So my dear students, remember, as the number of atoms in the molecule increases, the structure of the molecule becomes complex. More the complexity of the structure, more is going to be the entropy. Right? At the same time, for the system, if entropy increases, if entropy of the system increases, we say its delta S is positive. And if entropy of the system decreases, we say its delta S is negative. These are few points which you need to remember before solving the theoretical questions which are based on entropy. First of all, entropy gives me the information about the degree of randomness, the degree of disorderness present in the system. More the disorder, more the randomness present in the system, more is going to be its entropy, right? Similarly, as the number of atoms in the molecule increases, the structure becomes more complex. More the complexity of the structure, more is going to be its entropy. As simple as that. Now let's try to understand and see what kind of questions can be framed. Tell me the answer of these questions. Simple questions. You need to compare the entropies of these two molecules, NO2 and N2O4. Just look at these two molecules. See, in which molecule the atoms are more? In which molecule the atoms are more? Quick, my dear students. I would say in N2O4, the atoms are more. More the atoms in the molecule, more complex the structure. More complex the structure, more is going to be the disorder. More is going to be the entropy. So entropy of N2O4 will be definitely more than that of NO2. Right? Similarly, my dear students, SO2, SO3. Look at the number of atoms. More the number of atoms in the molecule, more is its entropy. As simple as that. CH4, C2H6. C2H6 will have more entropy. Okay? These sort of questions are frequently asked. These sort of questions are frequently asked, people. These sort of questions are frequently asked. What is the sign of delta S for the following processes? What is the sign of delta S for the following processes? Let's have a look, people. Let's have a look. Let's have a look. For example, if you look at the first question, the reaction that's given to you is H2 gas. It gives 2 times H gas. H2 gas gives 2 times H gas. Right? This is the question. I have to check during this process whether entropy is increasing or decreasing. During this process, entropy is increasing or decreasing. How do I check it, people? How do I check it? If you look carefully, what is the stoichiometric coefficient here? That's 1. What is the stoichiometric coefficient here? That's 2. So during the process, you know, stoichiometric coefficients are treated as moles. Stoichiometric coefficients are treated as moles. So during the process, are the moles increasing or decreasing? I would say the moles are increasing. If moles are increasing, you can say particles are increasing. If particles are increasing, you can say degree of randomness or disorderness increases. And when degree of randomness or disorderness increases, you can say entropy increases. And if entropy increases, you can say the sign of delta S will be positive. So talk in terms of stoichiometric coefficients, right? Okay. Number 2, second question. Look at the second question. My dear students, if you look at the second question, the reaction that's given to you is SO2 gas plus, this is half of O2 gas, okay? Just modify it. This is half of O2 gas. It gives what? It gives your SO3 gas, right? So first of all the reactants products are in gaseous phase. If all the reactants products are in gaseous phase, you need to use the same concept that I used here. First of all, look at the stoichiometric coefficient here, 1. Look at the stoichiometric coefficient here, 1/2. Stoichiometric coefficients, I'll be treating them as moles. So how many moles do we have on the reactant side? 1 plus 1/2, that's 3/2. 3/2 means 1.5. How many moles do we have on product side? 1. So during the process, are moles increasing or decreasing? Moles are decreasing. If moles are decreasing, entropy will be decreasing. If entropy is decreasing, delta S sign will be negative, right? Delta S sign will be negative. Perfectly done. Look at the next question, guys. The third question. The third question that we have got carbon dioxide solid. It gives carbon dioxide gas. Now, is the state same or different? The state is different. The state is different. This is solid. This is gas. The state is different. So I'm not going to use this concept. Right? I'm not going to talk in terms of stoichiometric coefficients. When do I talk in terms of stoichiometric coefficients? I talk in terms of stoichiometric coefficients when the state of all the reactants and products is gas. I talk in terms of stoichiometric coefficients when the state of all the reactants and products is gas, basically. But here, the state is different. This is solid, this is gas. So I'm not going to talk in terms of stoichiometric coefficient. I'll just talk in terms of state. I'll just talk in terms of state. How exactly? Have a look. This is solid. This is gas, right? So solid is basically getting converted into gas. Solid is basically getting converted into gas. Now you tell me, if solid is getting converted into the gas, what will happen to the disorder? It will increase. If disorder increases, entropy increases. If entropy increases, that means the sign of delta S here again is going to be positive. Right? Look at the next case, my dear students. Liquid is getting converted into solid. Liquid getting converted into solid. If liquid is getting converted into solid, that means disorder will be decreasing. Liquid getting converted into solid. In solid, you have got ordered arrangement. In liquid, you have got comparatively disorder present. So your liquid is getting converted into solid. So that means disorderness is decreasing. During the process, if disorderness decreases, that means entropy decreases. If entropy is decreasing, that means delta S here will be negative. As simple as that, right? Diamond is getting converted into graphite. Diamond has got more ordered structure. Graphite has got comparatively disordered one, you can say, right? So during the process, disorderness increases. If disorderness increases, entropy increases. If entropy increases, delta is positive, right? Now, gas, but here you have got solid. So you are not going to talk in terms of stoichiometric coefficient, right? You are not going to talk in terms of stoichiometric coefficient. Now, my dear students, how do you solve this question? Have a look. This is gas, this is gas. So on reactant side, you have got gases. On product side, you have got solid. So basically, gases are getting converted into what? Gases are getting converted into solid. And when gases will be getting converted into solid, that means disorderness will be decreasing. If disorderness decreases, randomness decreases. If randomness decreases, that means entropy decreases. And if entropy decreases, delta S sign will be negative. I want you guys to let me know in the chats whether you can solve these sort of questions from now on or not. Quickly in the chats, people. Let me know quickly in the chats. Will you be in a position to solve these sort of questions on your own now? Yes or no? Yeah, everyone. Everyone, people. Perfect. Perfect, guys. Perfect. Perfect. All right. Tell me the answer of this question. This is something you know more than me because I have been a pure PCM student. Okay? I was not a PCB student. Quickly, guys. What happens to the entropy during boiling of egg? When you boil an egg, what happens to entropy? So basically, when you talk about egg is in liquid state, and when you boil it, when you heat it up, it gets converted into solid. If you think normally, your liquid is getting converted into solid. If liquid is getting converted into solid, that means technically randomness should decrease. Randomness decrease, that means entropy should decrease. But in reality, entropy increases. And delta sign is positive here. Why is that? What is egg basically? Egg is protein. Right? Happened to the board, okay. Egg is basically your protein. Right? And I believe all of you know the structure of protein, right? My dear students, when you boil this egg, when you heat it up, what happens to the structure of protein? First of all, when you heat it up, the structure first unfolds. Then it refolds. Then it refolds again. And at the end, it becomes tangled. So when you boil an egg, so structure first unfolds, then after continuous heating, it refolds, and the structure becomes tangled. Tangled means more complex structure. Tangled means more complex. So basically, when you are heating the egg, the structure is becoming complex. And if structure becomes complex, entropy increases, right? Entropy increases. And if entropy increases, you know, delta S is positive. So remember, during boiling of egg, entropy increases, delta S is taken as positive, right? Now, my dear students, one last case here. When you stretch a rubber, what happens to its entropy? Quick. When you stretch a rubber, what happens to its entropy? Quickly, guys, what do you think? When you stretch a rubber, what happens to its entropy? You should be in a position to tell me. See, basically, if I'll be having an unstretched rubber, I've got, for example, an unstretched rubber, which I've not stretched, right? Which I've not stretched yet. Now I'm going to stretch this rubber. When I stretch this rubber, I get a stretched rubber. On one side, I have unstretched rubber. On another side, I've got stretched rubber. My dear students, if you talk about the unstretched rubber, the structure of unstretched rubber, it's coiled. It is in the form of coil. It is in the form of coils, like this. The unstretched rubber is in the form of coils like this. When you stretch it, these coils, they attain the linear shape. When you stretch it, they attain the linear shape. Now, if I ask you, which structure is more complex, this or this? I would say this is more complex structure. More complex means more entropy, right? More entropy. On this side, less entropy. So during the process, what is happening to entropy? Increasing or decreasing? It is decreasing. And decreasing entropy. During the process, entropy is decreasing. If entropy is decreasing, what will happen to the sign of delta S? Delta S is absolutely going to be negative, right? So when you stretch the rubber, entropy decreases. Perfect? So all these sort of questions can be asked in your NEET examination for sure in the theoretical question part. I hope this is clear to everyone. Now, my dear students, after discussing this, there is one more small topic which I would want to share with you. What is that? The topic is from thermodynamics only. And what is the topic name? That is the relation between delta H and delta U. A relation between delta H and delta U. This is again a topic from which frequently you will be getting the questions. A relation between delta H and delta U. My dear students, the general relation between delta H and delta U is something like this. Delta H is equal to delta U plus delta of PV. This is the direct result which I'm giving you between delta H and delta U. But my dear students, how do we use it? Before showing you how to use this, there are a few things which I would want to share with you. What is that? See, first of all, whenever you get a question based on a relation between delta H and delta U, this is the general relation, right? Now, my dear students, you need to look at the question. You need to see if pressure of the gas is kept constant or not. If pressure of the gas is kept constant, if this equation is written at constant pressure, it becomes something like this. Delta H is equal to delta U plus, take P out, it becomes P delta V. Delta V means final volume minus initial volume. This is the equation which I'll be using when pressure of the gas is kept constant. Similarly, if volume of the gas is kept constant, what kind of equation I'll be using at that time? Look at this general equation. I'll write delta H is equal to delta U plus, volume is kept constant, take volume out, it becomes V delta P. Delta P means P2 minus P1, final pressure minus initial pressure. This is the result which I'll be using when volume of the gas is kept constant. Got it? When volume of the gas is kept constant. Perfect. Now, my dear students, if for example, pressure and volume both are changing, if pressure and volume both will be changing, then what kind of the equation I use? The equation is going to be delta H is equal to delta U plus, it's going to be P2 V2 minus P1 V1. This is the equation which I'll be using when pressure and volume both will be changing. Now, at the same time, one more thing. After that, I'll show you how do I apply these equations in the questions. So first of all, the next thing is I'll write for a gaseous phase reaction. For a gaseous phase reaction carried out at constant temperature. If you will be given with a reaction which will be carried out at constant temperature, for example, the reaction is like this: N1A gas plus N2B gas, it gives, for example, N3C gas plus N4D gas plus N4D gas, right? Let's say this is a gaseous phase reaction which is being carried out at constant temperature. What is the relation between delta H and delta U here? It's going to be delta H is equal to delta U plus delta NGRT. Delta H is equal to delta U plus delta NGRT. Now the point is, what is delta NG? Delta NG is nothing but it is number of moles of gaseous products minus number of moles of gaseous reactants. Number of moles of gaseous products minus number of moles of gaseous reactants. For example, look at this particular reaction. I want to calculate delta Ng for this reaction. Delta Ng for this reaction will be number of moles of gaseous products. This is a gaseous product. This is the gaseous product. So how many moles of this? N3. How many moles of this? N4. So number of moles of gaseous product will be N3 plus N4. Minus number of moles of gaseous reactant will be N1 plus N2. These are first of all the results which you need to remember. Now, my dear students, I'll show you how to apply these results in the questions. But before that, what is the general relation? Delta H is equal to delta U plus delta PV, right? If pressure is kept constant, then P delta V. Volume kept constant, V delta P. If pressure, volume both are changing, P2 V2 minus P1 V1. If you will be having a gaseous phase reaction carried out at constant temperature, then the equation is going to be delta H is equal to delta U plus delta NGRT. I believe I'm clear with this. Yeah, I believe people I'm clear with this. Now, let me show you what kind of questions can be framed from this topic. Look at this question, guys. These sort of questions frequently you'll get in the examination. Look at this one, quick. Look at this one. My dear students, 1 mole of an ideal gas undergoes a change in state. 2 atm, 3 liters. So as per the question, this is the initial pressure of the gas. This is the initial volume of the gas. Now, the final pressure of the gas is kept 2 atm and the final volume of the gas is kept 7 liters. Right? This is the final pressure of the gas. This is the final volume of the gas. Correct? Correct, people? So the gas is undergoing a change in state. And when the gas is undergoing the change in state, delta U is given to me as per the question. How much? 30 atm liter. What am I supposed to calculate? I'm supposed to calculate delta H. Delta U is given. Delta H is to be calculated. Delta U is given. Delta H is to be calculated. Now you tell me one thing. This is basically the initial state of the gas. And this is basically the final state of the gas. So technically, I would say the state of the gas is changing. But look carefully. No doubt the state of the gas is changing. But is the pressure of the gas changing? No. Pressure of the gas is remaining the same. So I would say P is constant here. And which relation we use when pressure is constant? The relation is going to be delta H is equal to delta U plus P delta V, which is V2 minus V1. So now I can say delta H is equal to, what is delta U? Delta U is given in the question 30. What is pressure? Pressure is 2 atm, right? What is V2 minus V1? V2 minus V1. 7 minus 3 is 4. So the value comes out to be 38 atm liter. So this is the value of delta H which I was supposed to calculate. Did you understand, people? How do we deal with such kind of the question? Quickly in the chats. Did you understand? Every one of you. Did you understand? Did you understand? Everyone? Okay. Now there can be similar question like this. For example, the question is like this. Let's say 1 mole of the ideal gas, whose pressure is, for example, 2 atm. Volume is, for example, 4 liters. Let's say temperature is 298 Kelvin. Now the gas is undergoing the change in state. Let's say this is 4 atm, right? Let's say this is, for example, this is, let's say 1 liter. right? And let's say this is, for example, 308 Kelvin. This is the initial state of the gas, and this is the final state of the gas. I'm just making the hypothetical question. Okay? And as per the question, for example, when the gas is undergoing a change in state, delta U is given to me as 30 atm liter. Now they are asking me to calculate delta H. They are asking me to calculate delta H. Will I be able to solve this? They have asked me to calculate delta H. If you look carefully, tell me one thing. Is the pressure of the gas remaining the same or changing? Pressure is changing. Volume is also changing. So pressure and volume both are changing. Pressure and volume both are changing. And when pressure and volume both change, which result do we use? Delta H is equal delta U plus P2 V2 minus P1 V1, right? So I would say delta H will be equal. Delta U is 30 plus P2 into V2. See, this is P1, this is V1, this is T1. This is P2, this is V2, this is T2, right? So P2 into V2, P2 into V2, 4 into 1 is 4, minus P1 into V1, P1 into V1, 4 into 2 is 8, right? So it's going to be 30, 4 minus 8 is minus 4, so it's going to be 26 atm liter, right? I just made it, it is a hypothetical question. I don't know whether the values are correct or not. I just give the question as such. Just to make you understand, in the question, the pressure and volume both can change. And if pressure and volume both change, the result which I'll be using is delta H is equal to delta U plus P2 V2 minus P1 V1. I believe I'm clear with this. And people, look at the next question. It's a very nice question. It's a very good question. It's a very good question, guys. Try to understand. My dear students, which of the following is correct? For the following exothermic reaction, the reaction that's given to me in the question they mentioned, the reaction is exothermic. Exothermic. In exothermic reactions, what happens to heat? Heat is absorbed or heat is released? In exothermic reactions, you should know heat is released, right? In endothermic reactions, heat is absorbed. In exothermic reactions, heat is released. So during this particular process, heat is released. And whenever heat is released by the system, as per the sign conventions, Q value is taken to be negative. So Q should be negative, but here they have mentioned Q positive. So this cannot be the answer. Okay. Now, I'll check whether W is negative or positive. First of all, check. This is in gaseous phase, this is in gaseous phase, this is in gaseous phase, this is in gaseous phase. So I'll be using the ideal gas equation. As per ideal gas equation is concerned, PV is equal to nRT, right? Heat, pressure, temperature constant, R is already constant, volume and moles, they are directly proportional. So first of all, how many gaseous moles do we have on reactant side? 3 plus 1, 4. How many gaseous moles do we have on product side? 1 plus 1, 2. So during this process, are the gaseous moles increasing or decreasing? I would say moles are decreasing. And if moles are decreasing, volume will be decreasing. Right? And decrease in the volume is what we call as compression. Whenever there is compression, work is done on the system. And whenever work is done on the system, W value is taken as positive, right? So in this particular process, I would say W value is going to be positive. But here they have mentioned negative, so this cannot be the answer. Now, take the relation between delta H and delta U. My dear students, first of all, if I ask you what is the delta Ng for this reaction, delta Ng will be equal to number of moles of gaseous products. So how many moles of gaseous products do we have? This is gas. 1 plus 1 is 2. Minus number of moles of gaseous reactant. This is gas. So 1 plus 3 is 4. So 2 minus 4 is minus 2. So delta Ng is minus 2. If delta H is minus 2, the result which we have, delta H is equal to delta U plus delta NGRT, right? So I can say delta H is equal to delta U, delta Ng is minus 2, this is R, this is T. Or I can say delta U is equal to delta H plus 2RT. Correct? Correct, people? Tell me just one thing. Look at this equation. I say, over here on the right side, you have to add this term. You're supposed to add this term to delta H. Then only it's becoming equal to delta U. right? You have to add this term to delta H. Then only it's becoming equal to delta U. So technically I would say, what does that mean? That means delta U is greater than delta H. So delta U is greater than delta H, which means delta U is not equal to delta H. Good one, right? Am I clear with this? Right, people? Let me know once in the chats. Perfectly done. Okay, I'm giving you one more question that can be also asked. This is the question. Frequently asked question in the JEE mains. So this will be the frequently asked question in the NEET as well, right? Because the level is same. Level is same. Asha, by the way, day after tomorrow is, it's Friday, right? On Friday on this channel, I'm going to take one session. Friday on this particular channel, I'm going to take a session. The session is top 100 questions of inorganic chemistry, right? And surely you can expect 10 plus questions from that particular session, directly or indirectly in the NEET examination. So do not effort to miss that particular session. Okay, let me call my team first to schedule that session. Just give me a second. I forgot to tell them. Okay, I forgot to tell them. Just a second. They'll forget otherwise. Timing is going to be 9 PM.
सर बोलिए।
हाँ जी गणेश।
हाँ बोलिए सर।
यार मेरा कल नहीं परसों का सेशन वो लाइव कर दो, वो ऑलरेडी स्केड्यूल्ड है, उसका थंबनेल में लगा दो, वो टॉप 100 क्वेश्चंस ऑफ इनऑर्गेनिक केमिस्ट्री वाला, ठीक है?
इंग्लिश पे ना?
हाँ, नीट इंग्लिश चैनल पे, ठीक है? वो अभी पब्लिक कर दो आप। हाँ
ओके सर, डन।
ओके ब्रो। Just give me a second, guys. Just give me a second. Okay. Let's continue. Look at this particular question, guys. The question is something like this. Your H2O liquid is getting converted into H2O gas. H2O liquid is getting converted into H2O gas, right? Now, my dear students, as far as the question is concerned, during this process, delta H is given as 40.66 kilojoules. During this process, delta H is given as 40.66 kilojoules. Okay? 40.66 kilojoules. As per the question, they have asked to calculate delta U. They have asked to calculate delta U, right? They have asked to calculate delta U. Calculate delta U when 2 moles of liquid water, vaporizes at 100 degrees centigrade. Temperature is 100 degrees centigrade, that means 373 Kelvin. Okay? Now see how I'm going to solve this sort of equation and remember the approach. Okay? First of all, my dear students, if I ask you what is the delta Ng for the reaction, delta Ng for this reaction is going to be number of moles of gaseous product, which is 1, minus number of moles of gaseous reactant. There is no gaseous reactant, so delta Ng is 1. Now, delta H is equal to delta U plus delta Ng RT. This is the result which we have. So delta U will be equal to delta H minus delta Ng RT. Delta U will be equal to, just a second. हाँ जी बताओ। तो इनको बोल दो थंबनेल अपडेट करने को। अभी आप सेशन लाइव रख दो, फिर थंबनेल अब जब आ जाएगा अभी तब लगा देना वो, ठीक है? ओके ओके, so delta U will be equal to delta H minus delta Ng RT. My dear students, look here, you might do a mistake. You might do a mistake in this equation. Why is that? Understand. I need to calculate delta U in kilojoules, right? I need to calculate delta U in kilojoules is equal to, if delta U is to be calculated in kilojoules, That means delta H has to be in kilojoules as well. And this term should be in kilojoules as well. If delta U is to be calculated in kilojoules, delta H should be also in kilojoules, and this term should be also in kilojoules. Now try to understand. What is delta H? Delta H is given to me as per the equation as 40.66. It's already in kilojoules. Minus, what is delta Ng? Delta Ng is 1. R value is 8.314. 8.314 joules per Kelvin per mole. R value is 8.314 joules per Kelvin per mole. So I have taken the value of R in joules here, right? Temperature is given to me in the equation, that's 373. But, be careful. I have taken the value of R in joules. That means this term right now will be in joules. This complete term right now will be in joules. But I want this term also to be in kilojoules. So I'm dividing this with 1000 so that it comes in kilojoules. When you solve this equation, my dear students, what do you get? You get the answer as 37.5. You get the answer as 37.5. And it is given in the options. It is given in the options. Majority of the students will take this one. But if you take this one, you're doomed. Why is that? Why is that? This is the value of delta U. This is the value of delta U for this reaction. This is the value of delta U for this reaction. This reaction means when 1 mole of liquid water is vaporizing. This is the value of delta U when 1 mole of liquid water undergoes vaporization. But as per the question, do I need to vaporize 1 mole of liquid water or I have to vaporize 2 moles of liquid water? I have to vaporize 2 moles of liquid water. This is the value of delta U when 1 mole of liquid water undergoes vaporization. Yeah? So, delta U when 1 mole of liquid water undergoes vaporization, that is 37.5. So therefore, when 2 moles of liquid water undergoes vaporization, delta U will be 37.5 multiplied by 2. The value comes out to be 75.1 kilojoules. So the correct answer is going to be this one. Okay, be careful with these sort of questions, guys. Be careful with these sort of questions. Again, I'm telling you, majority of the students will make a mistake in the NEET examination in this question, if it is asked. And trust me, these sort of questions are frequently asked. Okay, particularly in JEE Mains examination. And if questions are frequently asked in JEE Mains, that means those questions will be frequently asked in NEET as well. So you need to be careful about that. Perfect. So this was the relation between delta H and delta U. Okay. My dear students, let's move on to one more topic. Let's move on to one more topic. One more topic. Lee-Chatelier's principle. I am not going to go into the details of Lee-Chatelier. I'm not going to explain you what is Lee-Chatelier. Then what am I going to do? I'm going to tell you those things with the help of which you can solve the questions based on Lee-Chatelier. Nothing more, nothing less. Okay? Got it? So my dear students, what Lee-Chatelier says first of all. In short, I'll tell you one statement. Just remember that. You can solve the questions based on that. The statement is, whenever you have got a reaction at equilibrium, whenever you have got the reaction at equilibrium, whatever you do to the reaction, whatever you do to the reaction, whatever you do to the reaction, equilibrium does opposite of that. Whatever you do to the reaction, equilibrium does opposite of that. What does that mean? You must be thinking, what does that mean? Let me tell you a few points here and we'll be sorted. See guys, the first point, understand it like this. For example, you have got the reaction like this, R gives P. This is the reaction, R gives P. The reaction is at equilibrium. The reaction is at equilibrium, okay? The reaction is at equilibrium. Now, my dear students, for example, let's say you are increasing the concentration of reactant. Let's say you are increasing the amount of reactant. The reaction is already at equilibrium. The reaction is already at equilibrium. Still, you are trying to increase the amount of reactant. If you are trying to increase the amount of reactant, system will shift in such a direction, equilibrium will shift in such a direction in which effect of change is nullified. What does that mean? That means whatever I'm doing, equilibrium has to do opposite of that. If I'm increasing the concentration of reactant, equilibrium has to decrease the concentration of reactant. How concentration of reactant can decrease? How concentration of reactant can decrease? How amount of reactant can decrease? When the reaction shifts forward. When the reaction shifts forward, concentration of amount of reactant will decrease automatically. right? So I would say in this particular case, equilibrium shifts forward. Simple. Whatever I'm doing, equilibrium is doing opposite of that. Nothing more, nothing less. Now, if I decrease the concentration of reactant, equilibrium has to increase it. How equilibrium will increase the concentration of reactant? It will shift the reaction backward. So the shift will be backward here. Do you understand what I'm saying? Yeah? Do you understand, people? Do you understand? Now, similarly, if I increase the concentration of product, equilibrium will try to decrease it. How? Backward shift. And similarly, if I decrease the concentration of product, equilibrium will try to increase it. How equilibrium can increase the concentration of product? It will shift the reaction forward. Okay. Now, here you have to take a note of one thing. What is that thing? If in a reaction there is some solid present, for example, the reaction is something like this. R gives P. Let's say this is in solid phase, this is in gaseous phase. If in a reaction there is some solid present, remember, on adding or removing a solid at equilibrium, remember, there will be no shift at all. When you add or subtract a solid at equilibrium, there will be no shift. Okay, there will be no shift. Perfect. This was point number one. Point number two. Since you know you have got two types of reactions. One is endothermic, and another one is exothermic. Remember one thing, in case of endothermic reactions, equilibrium constant is directly proportional to temperature. In case of exothermic reactions, equilibrium constant is inversely proportional to temperature. My dear students, remember, in short, when you increase the temperature in endothermic, when you increase the temperature, there will be always forward shift. And in case of exothermic, if you increase the temperature, there will be always backward shift. In short, remember these 2 points. Okay? In endothermic reactions, when you increase the temperature, equilibrium shifts forward. In exothermic reactions, if you increase the temperature, equilibrium shifts backward, right? This was point number 2. Similarly, point number three. On increasing the pressure, remember, equilibrium shifts in the direction in which gaseous moles decreases. When you increase the pressure, equilibrium will shift in the direction in which gaseous moles will decrease. For example, let's say you got the reaction like this. PCl5 gas, it gives PCl3 gas plus Cl2 gas. Tell me one thing. How many gaseous moles on this side? 1. How many gaseous moles on this side? 1 plus 1 makes it 2, right? So in the forward direction, gaseous moles are increasing. In the backward direction, I would say 2 to 1, gaseous moles are decreasing, right? Now, if I increase the pressure, right, equilibrium will shift in the direction in which gaseous moles are decreasing. In which direction gaseous moles are decreasing here? Backward. So equilibrium will shift in the backward direction. Do you understand what I'm saying? Equilibrium will shift in the backward direction. Perfect. So on increasing the pressure, equilibrium shifts in the direction in which gaseous moles decreases. But remember here one thing. For the reaction whose delta Ng is 0. Few minutes back, I've told you what delta Ng is. Number of moles of gaseous product minus the number of moles of gaseous reactant. For the reaction whose delta Ng is 0, if you increase the pressure, there'll be no shift. If you increase or decrease the pressure, there'll be no shift. Remember this point as well. That particular reaction whose delta Ng is 0, right? When you increase or decrease the pressure, there'll be no shift at all. Okay? There'll be no shift at all. Perfect? Now guys, just tell me one thing. For example, I've got the reaction like this. N2 gas plus 3 times H2 gas gives what? Gives 2 times NH3 gas. How many gaseous moles do you see here? 3 plus 1, 4. How many gaseous moles do you see here? 2, right? In the forward direction, gaseous moles are decreasing. In the backward direction, gaseous moles are increasing. In the forward direction, gaseous moles are decreasing. In the backward direction, gaseous moles are increasing. For example, if I increase the pressure, system equilibrium shifts in the direction in which gaseous moles decreases, right? In which direction gaseous moles are decreasing here? In forward direction. So here, the shift will be forward, right? Okay, remember this point as well. So 3 points I've discussed till now. My dear students, the fourth point. What is that? On adding an inert gas, I'll show you the questions in some time, right? First of all, let me write all these important points. On adding the inert gas at constant volume, remember there'll be no shift. If in the question they say that you have to add an inert gas, let's say there is a reaction at equilibrium. Now in the question they are saying you have to add an inert gas at constant volume. Remember, on adding the inert gas at constant volume, there'll be no shift. Okay, there'll be no shift. Perfect. Similarly, my dear students, fifth point. On adding the inert gas at constant pressure. Remember, system equilibrium shifts in the direction in which the gaseous moles increases. One more point. On adding inert gas at constant pressure, equilibrium shifts in the direction in which gaseous moles increase. But at the same time, that particular reaction whose delta and G is zero. Remember, on adding the inert gas at constant pressure, there'll be no shift. Okay, there'll be no shift. Similarly, sometimes they'll mention on adding the catalyst. What will be the direction of shift? Nothing. On adding catalyst, nothing. Now see how you can easily solve the questions. If you remember them all directly, my dear students, you can solve the questions. Sir, thermodynamics part 2. Which channel you are talking about? Are you talking about this channel or Unacademy J&K channel? On this channel already, you just search thermodynamics with Wassim sir. You will get a session in which I have completed thermodynamics in 8 hours and 49 minutes. Watch that session for thermodynamics. If you want thermochemistry, type on YouTube thermochemistry by Wassim sir. You'll get a session on thermochemistry as well, wherein I have completed thermochemistry in 3.5 hours. Right? Okay. Got it, people? So should we solve the questions now? Is everyone ready? People? So let's quickly recap it. I think there is no need to recap. You know it already. So chalo, I'm directly going for the questions. This is the question. First question. The reaction is given. Okay. More H2 is added. If you are adding more H2, equilibrium has to decrease it. How equilibrium will decrease H2? Forward shift. So here the shift is forward. If NH3 is added, if you add NH3, equilibrium has to decrease it. How it will decrease NH3? Backward shift. With the help of backward shift. In the reaction, if you see, it is plus 100 joules. That means heat is absorbed. If heat is absorbed, that means the reaction is endothermic. Now, temperature is increased. In endothermic reactions, when we increase the temperature, shift is forward. Inert gas is added at constant volume, no shift. Inert gas is added at constant pressure. When inert gas is added at constant pressure, equilibrium shifts in the direction in which the gaseous moles increases. Now, in which direction gaseous moles are increasing? Backward. So, here the shift will be backward. Because in the forward shift, gaseous moles are decreasing. In the backward shift, gaseous moles are increasing. Right? Done? Done, people? This was, for example, one of the questions. Tell me about this one. Reaction is given. Equilibrium is attained at something. Over here they mentioned closed vessel, closed container. What does that mean? Closed container means volume is constant. And you are adding inert gas. So inert gas is added at constant volume. Inert gas is added at constant volume. My dear people, if inert gas is added at constant volume, will there be any shift? No. If there is no shift, there will be no change in the concentrations of reactants and products, right? No change in the concentrations of reactants and products. Do you understand? I believe yes. I believe yes. Tell me the answer of this question. Tell me the answer of this question. I want to see. When NaNO3 is heated in a closed vessel, okay, oxygen is liberated and NaNO2 is left behind at equilibrium. What will happen? So first of all, you should know what's the process, what is happening basically. So as per the question is concerned, you have got NaNO3 solid. You have got NaNO3 solid. You are heating it up. And when you are heating it up, it's getting converted into NaNO2 solid, right? And with that, you will be getting O2 gas as well. You will be getting O2 gas as well. I wrote the reaction in the balanced form. Now, in the question, what they are saying, when NaNO3 is heated in a closed vessel, oxygen is liberated, okay? NaNO2 is left behind. At equilibrium, what will happen? What will happen? First of all, you're heating this up. You're heating this up. Okay? Now, addition of NaNO2 favors reverse reaction. Is it right? NaNO2 is in solid phase. And on adding solid at equilibrium, no shift. No shift. Addition of NaNO3 favors forward reaction. NaNO3 solid, right? This is also solid, this is also solid. If you add them or subtract them, right, there'll be no shift. So there's no shift here. Perfect. Decreasing the temperature favors forward reaction. Decreasing the temperature favors forward reaction. Reaction is endothermic. You're heating it up. You're decomposing it. You're heating it up. It is endothermic. If it is endothermic, in case of endothermic reactions, on increasing the temperature, there'll be forward shift. That means on decreasing the temperature, there'll be backward shift. Now what they are saying, on decreasing the temperature, forward shift. On decreasing the temperature, backward shift. So this is wrong. So automatically this is correct one. Understood? Understood, guys? These sort of questions will be asked. These sort of questions will be asked. Tell me the answer of this question. What do you think about this question? I want answer from you. I want answer from you now. I want the answer from you. Quick. Quickly, guys. I want the answer from you. What's the answer? Okay, the question is saying the equilibrium amount of carbon dioxide can be increased by. So we have to increase the equilibrium amount of carbon dioxide. How the amount of carbon dioxide can be increased? When the reaction shifts forward. How the carbon dioxide amount can be increased? When the reaction shifts forward. And when will reaction shift forward? Reaction will shift forward if you increase the amount of reactants. If you increase the amount of reactants, equilibrium has to decrease it. How? Forward shift. In any of the options, do you see the amount of your carbon monoxide or water is increasing? In the last option, if you see, when you increase the amount of carbon monoxide, equilibrium has to decrease it. How? Forward shift. Done? Option D. This is correct. Done, people? Okay. So with this, your Chatelier is also done. If Chatelier is done, let's move on to one more topic, small topic. Arrhenius concept, Arrhenius equation. Okay, my dear students, Arrhenius equation. Let me first of all write the Arrhenius equation. Arrhenius equation says that your rate constant of the reaction K is equal to A e raised power minus Ca by RT. This is your first form of Arrhenius equation. K is equal to A e raised power minus Ca by RT. Now, first of all, you should know what are these terminologies here. K represents rate constant of the reaction. K represents rate constant of the reaction, right? This e raised power minus Ca by RT, e raised power minus Ea divided by RT. This is what you called as Boltzmann's factor. This you call as Boltzmann's factor. This is what you call as Boltzmann's factor. At the same time, this A over here, this A is called as pre-exponential factor. You call it as the pre-exponential factor. Or you can call it as the frequency factor as well. You can call it as the frequency factor as well. And remember, this A takes into account two things. This A, it takes into account two things. One is called as collision frequency and orientation factor. This A takes into account two things, collision frequency and orientation factor. My dear students, at the same time, what this Arrhenius equation says? Arrhenius equation simply says that when you increase the temperature of the reaction, rate constant of the reaction increases, due to which rate of the reaction increases. The reaction speeds up. Simple. The reaction speeds up. As per the Arrhenius equation is concerned, when you increase the temperature of the reaction, rate constant of the reaction increases, due to which I would say rate of the reaction, the speed of the reaction increases. Number one. Number two, my dear students, number two, on increasing the temperature by 10 degree, on increasing the temperature of the reaction by 10 degree, remember, rate constant doubles or becomes even more. Rate constant doubles or becomes even more. When you increase the temperature of the reaction by 10 degree, rate constant of the reaction doubles or becomes even more, right? That means the rate of the reaction doubles or becomes even more, okay? At the same time, one more point. I am defining a term that's called as temperature coefficient. Which I represent with N, right? And temperature coefficient is nothing but it is a rate constant of the reaction at temperature T plus 10 degree divided by rate constant of the reaction at temperature T. Temperature coefficient is nothing but rate constant of the reaction at temperature T plus 10 divided by rate constant of the reaction at temperature T. Let's say at temperature T, rate constant of the reaction was K. Now, at temperature T plus 10, rate constant can be 2K, it can be 2.1K, 2.2K, 2.3K. Let's say it is 2K. So K gets cancelled. So temperature coefficient value here comes out to be 2. But if it is 2.1K, then it becomes 2.1, 2.2K, 2.2. So that means your temperature coefficient N, its value is greater or equal to 2. And remember, its value is less than 3. This can be directly asked. Temperature coefficient greater or equal to 2, less than 3. Okay. Few more important points, guys. Few more important points which I want to share with you. Remember that a reaction cannot have zero activation energy. Activation energy of the reaction cannot be zero. Okay, remember this particular point directly. It was asked in your NEET 2022, I think, or 23. A reaction cannot have zero activation. Okay. One more thing. I want to share that with you. What is that? For example, you have got the reaction A gives B. Here you have got the reaction C gives D. Okay. Let's say the initial temperature of both the reaction is same. This reaction is, for example, carried out at temperature, let's say 25 degrees centigrade. Even this reaction is carried out at temperature 25 degrees centigrade. Both the reactions are carried out at same temperature. This reaction is carried out at 25 degree. Even this reaction is carried out at 25 degrees centigrade. For example, imagine that activation energy of this reaction is, for example, 10 kilojoules. Activation energy of this reaction is, for example, 20 kilojoules. Activation energy of this reaction is 10 kilojoules. Activation energy of this reaction is 20 kilojoules. Now, for example, you are increasing the temperature of the reaction. Even you are increasing the temperature of this reaction as well. And if you are increasing the temperature of this reaction by, for example, 10 degree, here also, for example, you are increasing the temperature of the reaction by 10 degree. So, you are increasing the temperature of the reaction by same amount. So what happens? When you increase the temperature Let's say you are increasing the temperature here. You are increasing the temperature here by how much amount? Delta T. You are increasing the temperature of the reaction by the same amount, delta T. Now you know, on increasing the temperature, rate constant increases. So rate constant of this reaction will increase, of course. Rate constant of this reaction will also increase. Rate constant of both the reactions will increase. But remember, rate constant of that reaction increases more, whose activation energy is more. Rate constant of this reaction will increase. Even rate constant of this reaction will increase. But rate constant of that reaction increases more, whose activation energy is more. Okay? I remember this particular point as well. So, on increasing the temperature, rate constant of that reaction increases more, whose activation energy is more. Remember this particular point also directly. Okay? Got it, people? Got it, got it, got it? One more thing which I want to share with you. What is that? For example, you have got the reaction A gives B. Let's say at temperature T1, rate of the reaction is R1. Now, you are changing the temperature of the reaction from T1 to T2. For example, you are increasing the temperature. For example, you are increasing the temperature. You are increasing the temperature, right? Rate of the reaction will increase. At temperature T1, rate of the reaction was R1. At temperature T2, rate of the reaction is R2. Now, is there any relation that relates all these four parameters? Yes, there is one result that relates all these four parameters. Remember, the result is like this. R2 is equal to, I'll write 2. Technically, it's N. The temperature coefficient. But I'm writing 2 raised power delta T divided by 10 multiplied by R1. Where do I use this equation? You must be thinking. Where do I use this equation? For example, they are giving a question like this. You are given with a reaction A gives B. Okay. Now they are saying on increasing the temperature of the reaction from 10 degree to 100 degree. On increasing the temperature of the reaction from 10 degree to 100 degree. How many times the rate of the reaction increases? What do you have to do? You'll write R2 is equal to 2 raised power delta T, change in temperature, final minus initial, that's 90 divided by 10 multiplied by R1. So your answer will be R2 is equal to 2 raised power 9 times R1. So rate of the reaction has increased 2 raised power 9 times. Simple. Got it? Got it, Bill? These sort of questions can be asked too. Okay? Remember them. Few more things about this Arrhenius equation here. What is that? See, guys. For example, if they give you a question like this, for a hypothetical reaction, A gives B. Let's say they are saying activation energy is equal to 0. I mentioned the reaction is hypothetical. For a hypothetical reaction A gives B, activation energy is 0. Now the question says, at 200 Kelvin, rate constant of the reaction is, for example, 2 into 10 raised power minus 1 second inverse. Calculate rate constant of the reaction at 500 Kelvin. Do you see this? Calculate rate constant of the reaction at 500 Kelvin. Do you see the question? Do you understand the question? The question is, you are given with a hypothetical reaction whose activation energy is 0. Okay, perfect. Got it. Now, at 200 Kelvin, rate constant of the reaction is this. They're asking me to calculate rate constant of the reaction at 500 Kelvin. If you look carefully, what is my Arrhenius equation? Arrhenius equation says that your K is equal to A, e raised power minus A by RT. Right? Now tell me one thing. If activation energy is equal to 0, if this term is equal to 0, if this term is equal to 0, this entire term becomes 0. Anything raised power 0 is 1. That means K is equal to A. K is equal to A. That means K here becomes temperature dependent or independent. K here becomes temperature independent. There is no T here in this equation now. There is no T here. That means K, rate constant, becomes temperature independent. That means if you change the temperature, that particular reaction whose activation energy is 0, Rate constant becomes temperature independent. That means if you change the temperature, nothing happens to rate constant. So whatever was rate constant value at 200 Kelvin, same is going to be the rate constant value at 500 Kelvin. So at 500 Kelvin, rate constant again is going to be the same. That is 2 into 10 raised power minus 1 second inverse. Understood? Got this particular concept? Let me know once. Got this particular concept, people? Okay. Now. Few more things about Arrhenius because this is an important one. So you need to understand it, learn it properly. My dear students, the first form of the Arrhenius equation, you know, K is equal to A e raised power minus Ca by RT. Okay. This is the first form of the Arrhenius equation. The second form of the Arrhenius equation, that is the ln of K is equal to ln of A minus Ea divided by RT. This is the second form of the Arrhenius equation. The third form of the Arrhenius equation is a log K is equal to log of A minus Ea divided by 2.303 RT. The next form of Arrhenius equation, that is a log of K2 divided by K1 is equal to Ea divided by 2.303 R 1 upon T1 minus 1 upon T2. The next form of the Arrhenius equation, you call that as a differential form. That is d upon dt of ln of K is equal to Ea divided by RT square. These are the different forms of the Arrhenius equation which can be asked. Different forms of Arrhenius equation. These are the different forms of the Arrhenius equation which can be asked. Now guys, here one more thing. They can ask you the graph between ln K and 1 by T. They can ask you a graph between ln K and 1 by T. The graph is going to be a straight line with negative slope, and remember its slope is equal to minus Ea by R, and its intercept is going to be ln of A. Similarly, they can plot a graph between log of K versus 1 by T. Log of K versus 1 by T, and this is a graph like this, and its slope here, remember it's minus Ea divided by 2.303 R, right? And its intercept here will be equal to log of A. Now see what kind of questions can be framed. Remove these two graphs, guys. One is between ln K versus 1 by T. Second one, log of K versus 1 by T. Right? So try to understand. Try to understand. For example, this is the question. Look at this question carefully. Will you be able to solve this? I just want to know. Will you be able to solve this? Quick. Anyone done? See guys, if you look carefully, the graph is between log K and 1 by T. Log K and 1 by T. Few minutes back I told you log K 1 by T. What is the slope of this graph? The slope of this graph will be minus Ea divided by 2.303 R. And slope is nothing but tan of theta. Tan of theta. See, theta is equal to tan inverse minus 3. If theta is tan inverse minus 3, that means tan theta will be minus 3. Tan theta will be minus 3. So minus gets cancelled. So I would say Ea will be equal to this into this. So it's going to be 3 into 2.303 into R. Now. The question says calculate Ea in kilojoules and kilocalories. Remember, that is entirely decided by the value of R. R has got 3 values. You must be knowing. One value of R is 8.314 joules per Kelvin per mole, right? Or for calculation purpose, you can take 25 by 3. Similarly, one more value of R is 0.0821 atm liter per Kelvin per mole, right? You can take its value exactly as 1 by 12. Similarly, the one more value of R is 1.98 calories per Kelvin per mole, or you can take its value approximately as 2. Okay, You can take its value approximately as 2. Now guys, the first question is calculate the answer in kilojoules. If you have to calculate the answer in kilojoules, so your activation energy will be 3 into 2.303 into R. I have to get the answer in kilojoules. So here I'll take this value, which is in joules. So it's 8.314. Since I took the value in joules, so this term is completely in joules, but I need the answer in kilojoules. So divide it with 1000. This answer will be in kilojoules, right? Similarly, second question. Calculate the answer in kilocalories. So which R value is in calories? This R value is in calories. So it's going to be 3 into 2.303. R value I'm going to take as 2, right? So right now, since I've taken the R value as in calories, so this answer is going to be in calories right now. So I'll be dividing it with 1000. Now it's going to be kilocalories. Perfect. So like this, questions can be framed. Got it? Like this, questions can be framed. I believe this is clear. I believe this is clear. Yeah? Right, people? Similarly, can you solve this sort of a question on your own? I'm giving this as the homework. I am giving this as the homework. Just tell me in the chats, will you be able to solve this question? See, K1 is given, K1 is given, K2 is given, T1 is given, T2 is given. But you have to convert them in Kelvin, right? So which equation I'll be using? I'll be using log of K2 divided by K1 is equal to EA divided by 2.303R into 1 by T1 minus 1 by T2. Right? Right, people? This is your homework question. So with this, your Arrhenius is also over. Your Arrhenius is also over. Now. Now, one more concept, that is questions based on electrode potential. The questions which are based on electrode potential. This is also frequently asked. Like they'll ask you, which of the following is a strong oxidizing agent, which of the following is the strong reducing agent, etc., etc. They'll ask you, right? How do I deal with such kind of the questions? How do we deal with such kind of the questions? First of all, I need to tell you certain things, right, which you should know. First of all, my dear students, remember something like this. If I write E naught of M gives Mn positive. If I write E naught of M gives Mn positive. E naught of M gives Mn positive. Tell me one thing. M gives Mn positive. See, oxidation state of M here is 0, here it is plus N. 0 to plus N means increase in the oxidation state. Increase in the oxidation state is what you call as oxidation. Increase in the oxidation state is what you call as oxidation. So this particular term here represents the standard oxidation potential. This particular term here represents the standard oxidation potential, number one. Number two, if I write E naught of Mn positive gives M. E naught of Mn positive gives M. If you look carefully, the charge on M here is plus N, the charge on M here is 0. So plus N to 0, plus N to 0. Decrease in the oxidation state. Decrease in the oxidation state is called as a reduction. So this particular term I'll be calling as standard reduction potential. This particular term I'll be calling as the standard reduction potential. Do you understand what I'm trying to say? And my dear students, remember at the same time, SOP of an element is equal to minus times its SRP. SOP of an element is equal to minus times its SRP. For example, if I write E naught of Zn gives Zn di positive. Let's say this value I'm giving as 0.76 volt. First of all, check, is it SOP or SRP? Is it SOP or SRP? See, 0 to plus 2, increase. Increase means oxidation. So this is SOP. So if I need to write its SRP, so it's going to be E naught of zinc di positive gives zinc, right? Plus 2 to 0, plus 2 to 0, decrease in the oxidation state, reduction. So this is now SRP. So its SRP will be minus 0.76 volts. You just have to change the sign, right? And people at the same time, remember, Whenever you see the hydrogen electrode, whenever you see the hydrogen electrode, for hydrogen electrode, for hydrogen electrode, for hydrogen electrode, SOP as well as SRP, both the values are 0. So you can write something like this. E naught of H2 gives H positive. E naught of H2 gives H positive will be equal to E naught of H positive gives H2, and both the values are 0 volts. This is SOP and this is SRP. Of which electrode? Of hydrogen electrode. Both are taken as 0 as per reference. As per reference. Now, what kind of questions can be framed from all this? Why am I teaching you all this? Why am I giving you all these points? Why am I giving you all these points? There is logic behind that. What is the logic? See, my dear students, remember, more the SOP of an element, more the SOP of an element, more the SOP of an element, more is the tendency of an element to undergo oxidation. More is the tendency of an element to undergo oxidation. More is the tendency of an element to undergo oxidation. Better is going to be the reducing agent. Better is going to be the reducing agent. And remember, more is going to be the reducing power. So basically, reducing power and SOP, they are directly proportional. Reducing power and SOP, they are directly proportional. They are directly proportional. They are directly proportional. Remember it directly. Reducing power, SOP, directly proportional. Similarly, more the SRP of an element, more the SRP of an element, more the SRP of an element, more is the tendency of an element to undergo reduction. Better is going to be the oxidizing agent. Better is going to be the oxidizing agent. More is going to be the oxidizing power. Now, oxidizing power and SRP. Oxidizing power and SRP. Directly proportional or inversely. I would say oxidizing power is directly proportional to SRP. Okay? These are the 2 points from which you can crack the questions easily. Now, what kind of the questions? Let's try to understand. What kind of the questions? Let's try to understand. For example, this is the question. You would have seen these sort of questions. You would have seen these sort of questions. Look at the question carefully once. Look at the question carefully once, guys. Quick, everyone. See, guys, how do I deal with such kind of the questions? Try to understand very properly. First of all, what do I have to calculate? I have to check strongest reducing agent. Strongest reducing agent, right? Strongest reducing agent. Reducing agent matlab reducing power, right? Is directly proportional to SOP. Few minutes back only I told you, right? Reducing agent or reducing power directly proportional to SOP. So I have to give the answer as per SOP values. I have to give the answer as per SOP values. Now look carefully. Are these SOP values or SRP values? Are these SOP values or SRP values? See, in every reaction, gain of electrons is happening. Gain of electrons means reduction. So these are SRP values basically. These are your SRP values. I have to give the answer as per SOP, right? So reverse the sign. So first one will be plus 2.37. Second will be plus 0.76. The next is going to be plus 0.73. Next is going to be plus 0.04. So these are what? These are SOP values. These are SOP values. So which one has got more SOP value? This is the maximum SOP value. Maximum SOP value will be for magnesium. Maximum SOP value will be for magnesium, right? So more the SOP, better the reducing agent. So magnesium is your better reducing agent. Magnesium is your better reducing agent. Understood? It is not Mg positive. See, reducing agent itself undergoes oxidation. Reducing agent itself undergoes what? Oxidation. Oxidation means loss of electrons. So Mg dipositive cannot be the reducing agent because it cannot undergo oxidation. It cannot further lose electrons. It has already lost 2 electrons. It cannot further lose electrons. You see? Okay, one more question. One more question. Look at this one. What do I have to check? The oxidizing power. You know, oxidizing power is directly proportional to SRP. SRP. What are these values? Are these SOP values or SRP values? Gain of electrons happening everywhere. Gain of electrons is what we call as a reduction. Gain of electrons is what we call as a reduction, right? So these are SRP values technically, right? So which one has got maximum SRP? Which one has got maximum SRP? Where do you see maximum SRP? This is the maximum SRP, right? In this particular reaction, which one is undergoing reduction? Reduction means gain of electrons. So cobalt tripositive is gaining electrons. So this is undergoing reduction. So this is the SRP value of this one, you can say. Cobalt tripositive. More the SRP, more the oxidizing power. So cobalt tripositive will have maximum oxidizing power. Followed by 1.67. This is the SRP for this Pb plus 4, right? So Pb plus 4 comes next. So it's going to be this option. Option B. Guys, do you understand what I'm saying? Is it clear? Do you understand what I'm saying? Is it clear? Everyone in the chats once? Everyone in the chats once? Do you understand what I'm doing? Is this concept clear? Just say it once in the chats, everyone. I don't know who are these nonsense people in between and talking some random stuff in some other language. Do you want me to block all of you? Well, I don't have to call anybody to block all of you, okay? I can do it myself here. If I see anybody texting in other language, some other language, I don't know what they're talking about, what nonsense, I'll throw you out of my class. You can go to some other channel. Not here. Who is this Saranya and all? Saranya, get the hell out of my class. I'm blocking you right now. You will never be able to comment on any of the sessions, nor will you be able to chat. Who are these people? Just write some stuff. I just want to see. Write something. Who is this Bhargav? Blocked. Who is this 4B? Blocked. Search some other channel for chit chatting and stuff. Whosoever disturbs you in the chats, just write the name, mention the name. I'll block them right now. I blocked like 6 people right now. Exactly. Go to some entertainment channel. There are a lot of entertainment channels. Right? Go there. Let people study. Okay, let's move on. Let's move on. So, I believe this sort of concept is clear. Okay, I believe this sort of a concept is clear. And if this is clear, tell me the answer of this one. First of all, are these SOP values or SRP values? Are these SOP values or SRP values? Just tell me that. In every reaction, do you see gain of electrons happening? Gain of electrons. See, zinc dye positive plus 2 electrons. Gain of electrons happen. Ayat, you can just drag the video a little back. It'll be a replay for you. Why you are spamming, bro? It's an online class. Use your common sense a bit. Drag the video a little back. It'll be a replay for you. I don't know what kind of brain you guys have. You're riding on my nerves now. Okay. In all these reactions, do you see gain of electrons happening? Gain of electrons is what you call as a reduction, right? So these are basically your SRP values, standard reduction potential. What do you have to calculate? Reducing power. You know you're reducing power. Reducing power is directly proportional to SOP. Reducing power is directly proportional to SOP. Now, these values are your SRP values. I have to convert them into SOP values. So minus means this will be plus 0.76. This will be plus 2.87. This will be plus 2.36, right? This will be plus 0.25. So these are now SOP values. Perfect. Now which one has got maximum SOP? This is the maximum SOP value. That's for calcium. More the SOP, more the reducing power. So calcium will have maximum reducing power. After calcium, which is the next value? Next is 2.36, which is for magnesium, right? So magnesium will come next, right? So this is going to be the correct answer. I hope this sort of equation is clear to everyone. Yeah? I believe this sort of a concept is clear, and you will be in a position to solve these sort of questions as well. Okay? Right? Perfect, guys. The next concept is calculation of solubility product. Calculation of solubility product, which you represent with KSP. Okay? How do you get the expression of KSP basically? Questions are asked from this as well, right? Solubility product. Solubility product. First of all, how do you get the expression for KSP? Understand. For example, you have got a saturated solution of this salt AB. You have got a saturated solution of this salt AB, right? Let's say this is your A positive and this is your B negative. First of all, if the solubility of this salt is S, understand, 1 mole gives 1, S gives S. 1 gives 1, S gives S. If the solubility of this salt was S moles per liter, I would say concentration of A positive in the solution will be again S moles per liter. This will be also S moles per liter. Now the point is, how do I write the expression for KSP? How do I write the expression for KSP? What you have to do? You have got only things to do with the products. You'll write concentration of A positive raised power stoichiometric coefficient, concentration of B negative raised power stoichiometric coefficient. Now, if I ask you, what is the concentration of A positive here? That's S. Concentration of B negative, S. So it becomes S ka square. So the expression for KSP here is S square. It is S square. Okay. For example, you have got a salt of the type AB2. You have got the salt of the type AB2. How will it dissociate? It is going to dissociate like this. A di positive aqueous plus 2 times B negative aqueous. This is how it will dissociate. Let its solubility is S. Now 1 mole gives 1, S gives S. 1 gives 2, S gives 2S. Right? If this was S moles per liter, now this is going to be S moles per liter. And this is going to be 2S moles per liter. Now, if I ask you to write the KSP expression, it's going to be simple. Concentration of A di positive raised power stoichiometric coefficient and concentration of B negative raised power its stoichiometric coefficient. So I would say KSP is equal to concentration of A di positive, that is S raised power 1, concentration of B negative, that is 2S raised power 2. So the value comes out to be 4S cube. The value comes out to be 4S cube. This is the expression for KSP for this particular salt AB2, right? Now, for example, you have got the salt of this type AB3. Tell me first of all how this AB3 will undergo dissociation. It will dissociate like this. A tri positive plus 3 times B negative. This is how it's going to dissociate. Let its solubility is S. This will be S. This will be 3S. Now, tell me the KSP expression. KSP expression is going to be concentration of A tri positive, that's S, raised power stoichiometric coefficient, that's 1. Concentration of B negative, that is 3S, raised power stoichiometric coefficient, that is 3. So the value comes out to be 27S raised power 4. 27S raised power 4. Right? This is how you get the KSP expression. This is how you get the KSP expressions. In general, I can use something like this as well. Let's say you have got the salt like this, AXBY. So first of all, how will it undergo dissociation? How will it undergo dissociation? First of all, you should know what is the charge on A, what is the charge on B. So do one thing, just crisscross the things. This Y, keep the charge here, right? This X will go here. Now, how many A particles you have? X. So X times A plus Y, okay, plus how many B particles you have? Y. So it's Y times B minus X. Now, if the solubility of this salt is S, 1 mole gives X, so S moles will give X times S. 1 mole gives Y, so S will give Y times S. So if I ask you, what is the KSP expression? KSP expression is going to be concentration of A plus Y raised power stoichiometric coefficient, that's X, multiplied by concentration of B minus X raised power stoichiometric coefficient, that's Y. So I would say KSP is equal to concentration of A plus Y. Concentration of A plus Y is X times S raised power X. Concentration of B minus X is Y times S raised power Y. So final expression is going to be X raised power X multiplied by Y raised power Y, S raised power X plus Y. Okay. This is the general expression of KSP for this particular salt. Okay. Now, one more thing which you should remember. Remember this particular salt as well, Hg2Cl2. This is called as mercurous chloride. Mercurous chloride. Remember this one. This undergoes dissociation in a special way. It undergoes dissociation like this. Hg di positive plus 2 times Cl negative. It undergoes dissociation like this. For example, if its solubility is S, this is going to be S because stoichiometric coefficient is 1. This is going to be 2S. Now, you can write its KSP expression. KSP expression will come out which directly 4S cube. Okay, 4S cube directly. Got it? Now, you can do some questions on this. Look at this question. This is 3.2 into 10 raised per minus 14. Okay, this 10 raised per minus 14. KSP for MgOH whole twice is given. We need to calculate its solubility. We need to calculate its solubility. If you look carefully, we are given with MgOH whole twice. We are given with MgOH whole twice. Tell me, how will it undergo dissociation? It will dissociate as Mg di positive, and with Mg di positive we'll get 2 times OH negative. Okay. Now, let its solubility is S. This will be S. This will be 2 times S. If you want to write the KSP expression, it will be 4S cube directly, right? You know it. So, S will be equal to S cube will be equal to KSP divided by 4, right? Or I can say S will be equal to KSP divided by 4 whole raised power 1 by 3. Okay, so S is equal to KSP divided by 4 whole raised power 1 by 3. What is KSP? KSP is given to me 3.2 into 10 raised power minus 14 divided by 4 whole raised power 1 by 3. So S will be equal to, this will be 0.8. Or I can say 8 into 10 raised power minus 15. Instead of 14, I can write minus 15 raised power 1 by 3. So this will becomes 8 raised power 1 by 3 is 2. This is 3135. So into 10 raised power minus 5. This is going to be moles per liter. This is how you calculate solubility. If KSP is given, this is how you calculate solubility. Okay, this is how you calculate solubility. Am I clear? Am I clear, people? Quickly in the chats. Yeah? Sir, I don't know how to write the reaction when compound is given. Do you want to know that? Do you want to know that? See how is it written. For example, you have got the compound like this, A2B3. This is the compound. Now you want to write the reaction, correct? You want to write the reaction. First of all, do the crisscross thing. Crisscross thing means this 3 will go here as the positive charge. This 2 will come here as the negative charge. Okay? Now, how many A particles you have? 2. So start with 2. This A is in which state? This A is in +3 state, right? Plus times. How many B particles you have? 3. And this B is in -2 state. This is your reaction. Okay, this is your reaction. For example, you have got something like this. A1B3. A1B3, right? Just do the crisscross stuff first. This 3 will go here. This 1 will come here. Now, how many A particles do you see? 1. And this A is in which state? +3. Plus, how many B particles? 3. And B is in which state? -1. So this is how you dissociate it. Okay? Understand and remember. So remember this from now on. Okay. There is one exception, that was Hg2Cl2. Hg2Cl2 does not dissociate the way we think. It dissociates as Hg2 di positive plus 2 times Cl negative. Now, can we solve this question also? See, I think the value here is slightly changed. It is 10 raised power minus 23 here. 10 raised power minus 23. Now, first of all, you have got Hg2Cl2. Hg2Cl2. Okay. How it undergoes dissociation? Hg2 di positive aqueous plus 2 times Cl negative aqueous. All right. Ksp value is given. What do we need to calculate? Solubility. Let its solubility is S, right? This is stoichiometric coefficient 1. Since 1 mole gives 1, so S gives S. 1 mole gives 2, S gives 2S. Now, how do I write the Ksp expression? You know it already. It's going to be 4S cube. Correct? Simple. So, S is nothing but it's going to be Ksp divided by 4 whole raised power what? Whole raised power 1 by 3. So, what is Ksp? Ksp is 10.8 into 10 raised power minus 23 divided by 4 whole raised power what? Whole raised power 1 by 3. So this value will come out to be 10.8 divided by 4 will come out to be 2.7 into 10 raised power minus 23 whole raised power what? Whole raised power 1 by 3. Now this can be written as 27 into 10 raised power minus 24 whole raised power 1 by 3. Correct? So this can be written as 27 raised power 1 by 3 is 3 and this is 3138. So 3 into 10 raised power minus 8 moles per liter. This is the solubility of the salt which I was supposed to calculate. Okay. Am I clear with this? Am I clear with this, people? Quickly. Everyone in the chats, is it clear? Is every single thing clear? Whatever I discussed till now? I think you will be in a position to solve such kind of the questions. Right? Sir, indicators heavy weightage or not? Indicator, see, if you search one of my lecture that I have taken in Game of NEET 3.0, the name of the chapter is Ionic Equilibrium. Ionic Equilibrium, when you search on YouTube, right, there is a series, Game of NEET 3.0. There I have taken Ionic Equilibrium. In Ionic Equilibrium chapter, I have given you one table. I have given you one table. And in that table, I have mentioned indicators. Which indicators are used when? So that table only you have to remember. The question will be memory based from that. The question will be memory based from that. Okay? All right? I hope this is also clear. I hope this is also clear. Now, guys, there is something called as Nernst equation. There is something called as Nernst equation. Questions are frequently asked from Nernst equation in JEE mains examination, in NEET also. So you should know how to deal with such kind of the questions. First of all, I'm going to write the Nernst equation. Your Nernst equation is nothing but it is E cell is equal to E naught cell minus 0.0591 divided by n log of QC. This is the Nernst equation, first of all. This is the Nernst equation. Okay? This is the Nernst equation. Now the point is, where all do I use this equation? Where all do I use this equation? In what kind of situations do I use this equation? Sometimes there will be a question asked. There will be a question asked, calculate the oxidation potential of the half cell. Half cell means electrode. Calculate the oxidation potential of the half cell. Whenever they ask you calculate the oxidation potential of the half cell, use the Nernst equation. How? Instead of E cell, you will write EOX. EOX represents oxidation potential of the half cell. Is equal. Instead of E naught cell, write E naught OX. E naught OX represents standard oxidation potential of the half cell. Minus 0.0591 divided by n log of QC. I'll show you its application in some time. First of all, I need to tell you certain equations, right? Which you need to write first. Sometimes they'll give you a question in which they'll ask you to calculate the reduction potential of the half cell. The reduction potential of the half cell. Now the point is, reduction potential of the half cell. How do I write its equation? Reduction potential of the half cell. How do I calculate it? Instead of E cell, I'll write ERAD, which is the reduction potential of the half cell, is equal. Instead of E naught cell, I'll write E naught RAD, which is standard reduction potential of the half cell, minus 0.0591 divided by n, and it's log of what? Log of QC. Log of QC. Okay. And when they ask you to calculate the EMF of the cell, then you have to use this particular equation. Okay. Sir, when will you start all chapters quick revision for the entire first hands like in NEET 2024, 2025? I'll be posting those sessions as well. Complete chapter in 15 minutes. Complete chapter in 15 minutes. That I'll be posting. You've got time for that. Just wait. First, let's complete this particular stuff. Okay. So these are, first of all, the three equations, my dear students, which you need to remember. Now, how do I use these three equations in the questions? That's the point. How do I use these three equations in the questions? That's our point. Yeah. First of all, tell me, are these equations clear? Yes or no in the chats once? Okay. See, guys, how do I deal with the questions? For example, the question is, calculate the oxidation potential of the half cell. Calculate the oxidation potential of the half cell. So first of all, in order to calculate oxidation potential of this half cell, first of all, tell me, what is the oxidation state of iron here? It is +2. Sorry. Oxidation state of iron here, that is 0. Oxidation state of iron here, +2. Right? 0 to +2 means increase in the oxidation state. Increase in the oxidation state is what we call as oxidation. So first of all, what is going to be my reaction? My reaction is pretty much simple. Reaction is, I have to calculate the oxidation potential. So I'll write the oxidation reaction. Oxidation reaction will be like this. Fe solid gives Fe di positive, and with Fe di positive, you'll be writing 2 electrons. You'll be writing 2 electrons. Got it? How many electrons do you see here? 2. So N value here is 2. N value here is 2. How do I write the QC expression? Start with the product. This is in aqueous form. The one that's in aqueous form, use the term concentration. Concentration of Fe di positive raised by stoichiometric coefficient. Divided by. This is in solid form. You have got nothing to do with the solid. Okay, this is QC. QC is equal to concentration of Fe di positive. Now, what is the concentration of Fe di positive? If you look carefully, it's 0.1. 0.1 means 10 raised power minus 1. So this is QC. You got the QC, you got the N value. What do we have to calculate? Oxidation potential. Oxidation potential is equal to E naught OX minus 0.0591 divided by N log of QC. Log of QC. So I would say EOX is equal to E naught OX. What is E naught OX? This is standard oxidation potential. This is standard oxidation potential. Look at the question. Are we given with standard oxidation potential or standard reduction? So +2 to 0. +2 to 0. Decrease in the oxidation state. Decrease in the oxidation state is called as reduction. So this is the standard reduction potential. What do I need? I need standard oxidation potential. So change the sign. Change the sign. It's going to be plus 0.44 minus 0.0591 divided by N. N value is how much? 2. Log of QC. Log of QC. QC value I got is 10 raised power minus 1. Now it's just the matter of calculation. 0.44 minus 0.0591 divided by 2 log of m raised power and n log m. So minus 1 comes to the front. Log 10 is 1. So solve this equation. Get the answer in volts. Right? Got it? Perfect. Okay. For example, you have got a question like this. If you look carefully, first of all, it's a hydrogen electrode. And you know SOP, SRP of hydrogen electrode is 0. SOP, SRP of hydrogen electrode is 0. What do we have to calculate? We have to calculate oxidation potential. We have to calculate oxidation potential. So first of all, oxidation state of hydrogen here is 0. Here hydrogen is in +1. So 0 to +1. Increase in the oxidation state means oxidation. So since I have to calculate oxidation potential, so which reaction I have to write? I have to write oxidation reaction. Right? Now, H2 is getting converted into H positive. So the reaction is going to be H2 gas gets converted into 2 times H positive aqueous, and with that you'll be writing 2 electrons. Because one hydrogen atom will be losing 1 electron. So 2 hydrogen atoms will be losing 2 electrons. So what is the N value first of all? I would say N value here is 2. Now, can you get the QC expression? QC is going to be start with the product. So concentration of H positive raised by stoichiometric coefficient divided by go to the reactant. This reactant is in gaseous phase. The one that's in gaseous phase uses pressure. What is the concentration of H positive? Concentration of H positive is 0.1, which is 10 raised power minus 1, square, divided by, what is the pressure of H2? Pressure of H2 is 10. The value comes out to be 10 raised power minus 3. 10 raised power minus 3 is QC. You got the N value, you got the QC value. Now what do we have to calculate? We have to calculate the oxidation potential. I can say oxidation potential is equal to E naught OX, standard oxidation potential, minus 0.0591 divided by N, and it's going to be log of what? Log of QC. Now, E0x, standard oxidation potential of the hydrogen electrode, that's 0. SOP, SRP of hydrogen is 0, minus 0.0591. What is the N value? N value is 2. Log of, what is QC? Raised power minus 3. Now, matter of calculation, solve it, get the answer, that's it. Right? That's it. Perfectly done. Perfectly done, guys. Sometimes they'll ask you a question like this. They'll give the reaction. They'll give, till now I was making the reaction, but sometimes they can give the reaction on their own. Like this question. They have given the reaction. They have given the reaction. What do you have to calculate? Reduction potential. Reduction potential, right? So first of all, the reaction that's given to me, let's get to know what is the N value here. You can see 1 electron, so N value is 1. What is the QC expression? Start with the product. So NO2 is in gaseous phase, so pressure of NO2, raised power stoichiometric coefficient. This is in liquid phase, I've got nothing to do with the liquid, divided by. This is in aqueous phase, so concentration of NO3, negative, raised power stoichiometric coefficient 1, H positive, aqueous phase, so concentration of H positive, raised power 2. Okay? N value is 1. Now the point is, calculate the reduction potential in the neutral solution. Calculate the reduction potential in the neutral solution. Neutral solution means pH is equal to 7. If pH is equal to 7, what will be the H positive concentration? That will be 10 raised power minus 7. If you do not know, whenever pH is equal to X, that means H positive concentration is 10 raised power minus 6. It is 10 raised power minus 6. Now, if I use the things in this particular expression, I can say QC is equal. What is the pressure of NO2? What is the pressure of NO2? Pressure of NO2 is equal to 1 bar divided by. What is the NO3 negative concentration? NO3 negative concentration is 1 molar. H positive concentration is how much? 10 raised power minus 7. 10 raised power minus 7 ka square is 10 raised power minus 14. So this value will come out be 10 raised power 14. So I got QC, I got N. What do I have to calculate? Reduction potential. I'll just use the Nernst equation. When reduction potential is to be calculated, I can say ERED, reduction potential of the half cell, is equal to E naught RED, which is the standard reduction potential, minus 0.0591 divided by N. That is going to be log of QC. Now the point is, what is this E naught RED? That's SRP. SRP. Am I given the SRP? Since in this particular reaction, gain of electron is happening. Gain of electrons is called as reduction. So this is SRP. So 0.78 minus 0.0591. N value here is 1. Log of QC is 10 raised power 14. Matter of calculation, and we are done. 0.78 minus 0.0591 log of m raised power n log m. So 14 into log 10. Log 10 is 1. Right? Solve this, get the answer in volt. Am I clear with this also? Am I clear with this also, people? Yes. Okay. I think this much is super sufficient for today. Yeah. Right, people? I think this much is super sufficient for today. I have to show you one session first of all. When you click on Unacademy NEET English, see, this is important, guys. Very, very, very important. When I go to the live section, okay, there is one session whose thumbnail is not given yet. Top 100 most expected questions of inorganic. Top 100 most expected questions of inorganic. My dear students, day after tomorrow, that means on Friday, at 8 p.m. or maybe 9 p.m., I'll be taking this session. Okay. And in this particular session, my dear students, I'll be discussing some 100 questions of inorganic. And in your actual NEET paper, you should be getting questions from this particular session only, from those 100 questions only, when it comes to inorganic chemistry. Okay, that's my promise to you. Right? So do one thing, right after the session, what do you have to do? You have to smash the like on this particular session. Do smash the like and click on notify me so that you remain updated about this. All right? Okay? Right after the session, go to this particular session, smash the like and mark your attendance. Day after tomorrow, I'll see you. Day after tomorrow, I'll see you exactly at 8 p.m. or 9 p.m. Okay, but I want every one of you to be there. Perfect. There are a lot of sessions which I have scheduled for all of you, lot of amazing sessions, these short sessions, 2 to 3 hour sessions, which will fetch you a lot of marks, guys. Okay, which will fetch you a lot of marks. And at the end of the session, do let me know in the comment section of this particular video how much you enjoyed this one and how much you got benefited out of this one. Okay, so with this, I'm going to take a leave. Take care, God bless you all. And the session PDF I'll be sharing on my Telegram channel. The name of the Telegram channel is Wassim Bhat Chemistry Official. WASSIMBHAT Chemistry Official is the name of the Telegram channel on which I shall be sharing the PDF of this particular.